Today on This Old House,
It takes a special 5-piece beam to open up our new kitchen to the living space.
This crabapple is healthy. It just needs a little haircut.
And 4 yards of concrete will keep this chimney up for another 100 years.
what happened to all this plumbing here?
I've never seen anything like this before. There's already rot going on in that trunk.
So what have you found up here?
Well, a bit of a surprise.
It's really the classic plumber's lament.
Nice.
It's 5 bathrooms, it's a kitchen, it's a full new mechanical. It's going to be a biggie.
Sounds like you guys have a plan.
I think we do.
Money's in the detail.
That is beautiful. Hi there, I'm Kevin O'Connor, and welcome back to This Old House here in Concord, Massachusetts, where we are working on this cape right here, built in the, good morning, Jeff. Good morning. This one's built in the 1880s, and a couple things to update you on. First of all, check out the two chimneys we have. Now, the one on the far side, we think that's original to the house, but as you come around here to the side, this second chimney right here, we believe was added when they put an addition off the back, and this one needs a little bit of work. Good morning, Norm. If you come in here and take a look at it, you can see that all of this chimney in weight is not sitting on a footing. That is just dirt right there. So that has to be addressed. You can see that there's a form going in, and that's because Charlie is going to pour a new footing and tie it right into this a little later today. Now here's the progress we've made out back. There is a big new addition going on. So the concrete walls have all been poured. You can see the work down here underneath is done. We've got the crushed stone compacted. And then we've got these footings right here because we're going to have a couple of posts, and they're going to be holding the beams that hold the first floor of the addition, which is going to be tied into the original house. And off the back right there, that was the old living room. The back wall has come off. There's going to be an opening to the new addition, and as is the case often these days, the homeowners want an open floor plan. So that means there has to be a big beam to clear open that space right there, and that's going in today. Hey, Tommy.
Yeah.
That beam ready to go in?
Yeah, if you're finished giving the tour, maybe you could go up and give somebody a hand here.
Giving a tour. All right, I'll go up and help you, Pops. So, as I said, this was the old family room, and now it's going to become the new kitchen. So the sink is going to go in front of that window, which is going to be changed. There's going to be a big island right here. These windows are getting changed out, but this fireplace, which is connected to that chimney that I was talking about, that actually stays. Hey, Charlie.
Kevin.
And then this right here, Tommy, is where we are putting in our new beam. My tour is done, so
Yeah, it's about
what do you
time.
got?
All right, so what we have to do is we have a beam that really has to be strong here because we're carrying a lot. This is going to open us right up. We
Yep.
have the kitchen, as you said, there with an island. And a little further into the new space is a big stairway that leads downstairs.
So carrying a lot meaning big wide open span, but also carrying all of the second floor and any
Second
of the
floor
roof?
and some of the roof load. And we have a point load over there we have to deal with also.
Gotcha.
So we're using a beam with engineered wood and steel.
Which is in you guys call that flitch?
It's a flitch beam, and it's a triple flitch beam.
So we got to actually marry it up to these existing joists?
Right, it's going to slide right in, and then once they're all cut, we're going to take the timber hanger like this, and we'll put underneath the joist and attach these to the new beam.
Gotcha. And so we got to make a little bit of room here for
Yep.
what's left?
All right, so we have 4 more joists to cut.
Okay.
All right, so here's the beam that's going to go into place. This is called a flitch beam. In this case, it's a triple LVL with 2 pieces of steel.
You guys made this up earlier today?
Yep, so we ordered the steel with the holes already drilled. They mark it with a pencil and then take the steel off and drill through it.
Okay.
Once it's all drilled, we sandwich it together, drive our carriage bolts through, and we're going to tighten those together with an impact driver.
You ready to fly this in?
We're ready to fly it in. One of the big advantages of a flitch beam like this, we could put each piece in individually. But when we have a machine like this and we can build it on the ground, it's a lot faster for us to do it that way. Now pull it over. Good. All right, try to slide it in. There you go.
All right, I'll clear.
Perfect.
Okay, it's sucked up
All
there.
right, good. All right, pull it away.
It's up nice and tight.
Yeah, our beam is up temporarily. Now, we've got a temporary post on each end. We're gonna move our post out so we can work on each end to form that new post. We've got to put all the metal hangers on to tie the existing joists into the new beam.
And now we got ourselves a really big opening. I love it.
Yeah, right now it's about 16 feet, but I think it's coming in just a little bit.
All right, I'll keep sinking these in here.
Okay.
Hemlocks in North America are confronted with a big problem called the woolly adelgid. So when we were here a few weeks ago, these underside of needles were smothered with this white puffy shell, just taking over all the undersides of the needles. And that's where the insects live. So what we did is treat these hemlocks with a horticultural oil, and the goal there was to smother and suffocate the insects. And since then, I am really not seeing any of the white specks, which are the woolly adelgid. In fact, I see new growth. It's pushing out these cones, and the tree is looking very healthy to me. But this isn't the only hemlock that's had problems. Hey, Clem.
Oh, hi, Jan.
So we checked this tree for the woolly adelgid. It seems to be okay, but we decided to treat it anyways, just in case. But I understand there's another problem we have.
Well, we have a structural problem. The tree has two leaders that come together in a narrow V crotch. And when that occurs, there's no good union between the two of them, and they frequently split apart during a storm.
Right.
So what we do to correct that is we install this 5/8 bolt, which in this case is 18 inches long. It's going to go through the tree, and then we're going to attach this 5/16 cable using these wraps, put another bolt on the other side, and we always put that thimble in place because we don't want these ends to wear, and that'll hold the cable for a good long time. And the nut on the other end of this is what's going to tension the cable.
Okay.
And we'll get that nice and taut, but we're not trying to pull them together. We're just trying to prevent them from splitting apart.
Right, and so the tree could flow as one union, one piece together instead of...
Splitting apart.
Right.
Exactly right.
Okay.
Some people think that this might be injuring the tree, but all the research on this indicates that the wound to the tree is quite minimal.
Right.
Much more damage occurs to trees when someone wraps a cable or a rope around the tree and
That'll
sort of
girdle.
strangulates or girdles the tree. And then within about 2 or 3 years, it'll be completely sealed. Now he's going to cut off the excess cable.
Okay, so now this is one tree that the homeowner was on the fence about taking down, and it's a beautiful crabapple. I think it just needs attention, right?
I agree, Jen. They flower so beautifully in the spring. And then if you pick the right crabapple that's disease resistant, you'll have good foliage all summer. And then in the fall, you'll get that extra kick from the fruit, the little berries there that ripens and just looks so gorgeous in the winter landscape.
It's just prolific color, and the wildlife love it. And in this natural setting, I think it's a perfect tree.
Well, that's right. The only problem with crabapple, it's a very aggressive grower, very vigorous. So what we're going to do is raise it up a little bit, make sure that any suckers that are coming up from the ground, from the roots, are cut back.
Right.
And we'll try to remove some of the verticals and just maybe make it a little more compact.
Right.
Let's step back a little bit and take a look at this tree from the homeowner's point of view.
It's always good to step back. And look at that shape. It's opened up, lift off the ground, contain.
Yes.
It's gonna have a new life and a new purpose.
Well, it's true. And what I really like too is seeing the structure of the tree.
It's beautiful.
That trunk and those branches, they
Right.
have character, don't they?
You took all the vertical suckers off and you really see that arching habit going
That's
over.
right. Yep.
So thank you and your team. I know you have more work to do.
We certainly do. There's a lot of trees out here. We're going to go work on the bald cypress after this and get all the vines out of it.
Excellent. Keep up the good work.
We're here at the chimney, probably built decades ago, maybe in the 50s, 60s, not really sure. But if you come down to where the footing is for underneath this chimney, you can see the gravel below it because now we've dug down below it for a new addition. There's the foundation right here. So we don't want this dirt to basically vibrate out or crumble away because we don't want the chimney to come down. So what we're doing right now is we're actually forming a form to make a new footing to hold all of this dirt and hold the chimney in place. Right now you can see that they're tying the rebar together to make a rebar mat up here into the form. When the concrete comes in, it's going to encapsulate that rebar and keep everything nice and tight. Concrete is really strong under compression, but you have to tie it together for tension, force this way, and that's what the rebar is doing. All right, our stone has all been compacted, our rebar is in place, the mat is made, our forms are ready to accept the concrete. Because of the pitch of the grade over there, we couldn't get this concrete truck down here, so we're using the steer skid loader to bring it around. Now he's running the vibrator into the concrete. What that's doing is taking the air out of it and moving it around so it lays down nice and flat. All right, here we go.
Well, 4,000 mix with 3/4 stone.
That's right, and 4 yards. 4 yards goes a long way.
Sure does. I know one thing, I'm gonna sleep a lot better at night knowing this is done.
Absolutely, I was always thinking about that chimney coming down off the house because the footing wasn't there. But now, problem solved.
It is.
Last time we started framing this dormer up here, we framed the cheek wall and the back wall, and we set a lot of the rafters in place. But because of this weather and everything, it's really slowed us down, and we really want to get this place sheathed. So we started installing the roof today, and we're going to do the cheek walls and the face also.
That's right. And remember, years ago, we used to use plywood and always had to cover it with some kind of protection. We started off with a rosin paper, a felt paper, and now we went to a house wrap.
Right. These products, like the rosin paper, was used behind, let's say, clapboards or shingles, and it was separation from the face of the sheathing to the back side of the siding, and that would allow the siding to move independently. And if any condensation, because we really took a lot of effort to keep the wall dry behind the siding, but if you got condensation in there, these two products would help absorb some of that. Now the house wrap came into play, and that was basically a so-called cure-all for these products. And this is a product that you put on the house, and you want to make sure that it's tight to the sheathing. You have to staple it. You also want to make sure that it's sealed to the foundation with tape, and all of your joints are taped. Now, to save a lot of work on installing all of these in the field, we're now using a product like this. This is a water barrier that basically comes coated onto the sheathing, and it's an air infiltration and a water barrier all in one. But there are a few rules that you have to follow with this as you would with plywood. You want to make sure that you space the joints out slightly, about 1/8 of an inch, And if you cut a piece, you should seal that cut joint. And you want to drive the nails where they go, but you don't want to overdrive the nail head. That nail head should be flush with the surface. If you drive it in through the thickness of the plywood or the sheathing here, and let's say you drive it down 1/8 of an inch, the raw fibers are exposed, and you want to make sure you seal those. So they have a liquid for doing that. You could just put a little dab on, like joint compound, or you could cut little pieces of tape. The liquid much easier. All the joints, in the seal, whether they're horizontal or vertical joints, they have to be taped right there. That's the tape. So this tape here would go on all the joints. You just put it on. Let's say we have a joint. It's good stuff. So you'd put it on. Underneath this would be a joint. And then you want to make sure that when this goes on the sheathing, this sheathing has to be clean. There shouldn't be any residue of sawdust on it. It should be clean from any dirt. Once it's on, you push it on like that, and then you roll it with a special roller. Now, if you look right there, that roller with these little pieces of metal right here, they've actually let little divots right in there. It tells the building inspector that this tape has been rolled and pushed tight against the board, and that's what you want.
And this is really the crucial part of this system too.
Absolutely. If it's not taped and rolled correctly, it could fail.
That's right.
All right, so we're ready to get some of this stuff on the wall.
Yeah, let's get it done.
Now, if you look at this nail here, or that one, it's good with the surface. It hasn't damaged the outer core. But when you go down here, this nail or this nail is driven a little bit too deep. So to seal that little imperfection, to make sure we get the maximum life out of our product, we're going to seal it with this liquid flashing. I'll do this one. All right, so now I've put plenty over the hole that the nail is set a little bit too deep. Now I'm just going to flatten it out. That's all there is to it.
Our sheathing came to us from Commerce, Georgia, where they've been making building products for more than 30 years.
It is a big and noisy facility, so we're fortunate to have the headsets to help us out, and very fortunate to have our plant manager, Mike, here.
Morning, Kevin. Great to have you with us here.
Yeah, well, thank you for the invite. So this is where it all starts, huh?
This is where it all starts. This is a Commerce, Georgia facility.
And so I look at all the feedstock back here. What species are you guys working with?
Southern yellow pine. We take it in from a 75-mile radius around the plant. We get about a little bit over 100 trucks a day.
And how many logs on each of those trucks?
About 28 tons.
28 tons.
28 tons.
Times all those trucks. All right.
And so we're singulating these logs one at a time, coming from our infeed deck, working their way up to the slasher deck, which is going to roll one log at a time into the conveyor. And this conveyor is going to then take the log down through a metal detector. We're checking for spikes, barbed wire, nails, anything that might damage our stranders in the process. This is a debarker. You see the feed rolls pulling the log into the machine. The log is going to be stripped of the bark.
And what happens to the bark?
It'll be the wet fuel for our furnace.
So what are we looking at here?
So right here we have a strander. It's a disc strander. It's like a big deli slicer in a sense. So we're taking the logs as they come in and creating dimensional pieces that we can use in our process down the line here.
So as I look behind me, these big iron bars coming down, they're holding the log in place while the cutter swipes across them?
That's correct. The hydraulics are holding the logs in place as the strander comes across, peels those strands out. It has 24 pie sections, and each one of those has 2 blades on it, so it has 48 knives on this strander. Those strander knives have to be changed out about every 6 hours before they dull.
That's a lot of sharpening and a lot of blade changing.
That's correct. So Kevin, this is where we set our knives up that go in the disc we just got finished looking at. This is a typical strand we see coming through the process. Again, about a 5-inch long, about 2 inches wide, and about the thickness of a business card is what we're looking for. Now, how do we get that strand out of the process of that disc? We have 48 of these knife blades inside that disc sticking out about the thickness of that business card to create that thickness there. The angle on the back side, which is called a counter knife, is what determines the width of that. So that angle, depending on how shallow or how gradual it is, creates the width, either a toothpick or I can create sheets of paper.
So already a lot of effort to get sort of this exact dimension.
That's correct.
Why is that so important?
The strand is the foundation of your panel. So getting the right strength characteristics in that strand, the right size strand, determines the strength of your panel at the end of it.
Gotcha. Oh, wow. So what are we looking at here?
So we're looking at our drying process here. We're taking the strands and we're going to run them through the dryer here. They started out at about 50% moisture content, and so now we have to dry them down.
If you're starting at 50%, what are you trying to get it down to?
We're looking at about 3 to 4% in our core and around 9 to 10% in our surface material.
So a lot of drying going on.
A lot of
here.
drying. We're going to go from about 1,500 to over 1,500 degrees Fahrenheit on the far end of the dryer to the front end would be around 300 degrees. Well, we have the formula line here where we're laying the strands, orienting them in the proper direction. We lay a bottom surface layer that is parallel. We'll have a core layer that will be perpendicular to the line, and then another layer on top that will be parallel.
And what does it do for you to have those layers come down parallel, perpendicular, and 3 of them?
So the reason to have them parallel and perpendicular is give you the bending strength and stiffness that we want.
Right.
It also gives us shear strength along with the density of that panel in that process. Also, in this product that we're making today, we have this integrated weather-resistant barrier. The green side is facing down. It provides an air barrier and a water barrier to the panel. Here in the control room, we operate both the drying process and the pressing process. He also controls the blending process, which is where the resin is integrated into our strands before they were formed on the mat. We're going to take this 5-inch mat we talked about coming down the line. Again, in this case, we're going to close it with over 4,000 pounds per square inch pressure. We're going to sit in that press at over 400 degrees Fahrenheit for 4 to 5 minutes.
Well, now they're starting to look like something I recognize.
That's right. They're going through a computer system that checks for surface quality. We also have gone through a blow detection device or delamination detection device, looking for delamination in the panel. And now these final A-grade panels are coming out with the logo and nail grid already installed. They're going down the line here, getting stacked up so they can be packaged. And at this point, we're putting them on the trucks, getting them ready to go to your project.
Nice. Mike, thanks a lot for the tour. Very insightful. We appreciate that, but we especially appreciate the material coming to the job site.
Thank you very much.
You got it. Thank you.
Next time on This Old House.
The new part is level, the old part is not. When we're through, you'll never know the difference.
So Karen, we've got the whole kitchen laid out pretty much and approved by the homeowners?
Yes, we have it all figured out.
This is where Charlie's bringing the addition in, as you can see by the footing. So we're going to follow that wall with a little bit of block because this elevation is going to be buried a bit. So we're going to want to make sure we keep Charlie's work above ground.